afternoon, depending on which class you're in. This is Mrs. Byrd. We're going to do a quick lesson today on writing equations from word problems. In front of you, you should have the packet that we started on Wednesday. The second page of that is titled Hands-on Equations, Verbal Problems. Make sure you have that in front of you before we get started. So again, our task is writing equations from word problems. So first I want to go over just some general steps for writing and solving equations. So I'll preface this by saying that we spent our whole last unit working on translating verbal expressions into algebraic expressions and vice versa. So we're doing essentially the same thing, except now we're writing equations, which means we'll have an equal sign. Remember, the difference between an expression and an equation is that an equation contains an equal sign. So we're going to write equations based on word problems. Alright, so these are just some general steps for writing and solving equations. It might be beneficial to take notes on this. But again, these are just general steps for writing and solving equations. So number one, you want to make sure that you define your variable. What does that mean? Well, you're going to pick a variable to use and explain what it stands for. You can essentially choose any variable that you like, but I would suggest that you choose one that closely represents what you're looking for. Alright, number two would be to set up or translate your equation. So you're going to read through the word problems and turn those verbal problems into, or verbal equations rather, into algebraic equations. And we'll practice some of these together, and I'll let you do some on your own as well. Number three, you're going to begin solving equations by simplifying or combining like terms on each side of the equation. This is what you did for homework last night. So you're still going to be using that same concept where you're simplifying both sides of the equation before you start moving things around and solving for your variable. Number four, you're going to solve your variable using inverse operations. It's important to remember that, or to know rather, that all word problems are different. You still have to use your problem solving skills and strategies that you've been using forever to solve these. Alright, so let's get right into it. Follow along with me as we do number one. And number one reads, 3 consecutive odd integers have a sum of 75. We're finding what those 3 integers are. Okay, so before we start doing this, let's go ahead and talk about some vocabulary here. It says 3 consecutive. Consecutive means back to back. For example, 1, 2, 3, 4, 5, 6, those numbers are consecutive because they occur right after each other. But this also says we need consecutive odd integers. What are odd numbers that are consecutive? Numbers like 1, 3, 5, 7, 9, etc. Alright, and then an integer is just a whole number or negative whole number. A whole number or its opposite is the definition of an integer. And we haven't worked with many negative numbers yet, so we're sticking with positive numbers for today. Alright, so again, I'll read the problem. 3 consecutive odd integers have a sum of 75. We're going to find the integers. Remember our first step, if we go back to our the steps that I just went over, the first step is to define our variable. So that's what we're going to do. Let's say, N. My name starts with an N, and so does the word number, so I'm going to use N. Alright, so we're looking for some number. We're going to let N stand for a number. Okay, think about this. If you had any number and you wanted its consecutive, I'm sorry, if you have any odd number, take any odd number, and you want to get its consecutive odd number, what would you need to do to that number to get the consecutive odd number? Well, you'd add 2, right? If your odd number is 1, to get to your next consecutive odd number, you would need to add 2. 1 plus 2 equals 3. So 1 is our odd number, 3 would be the next consecutive odd number. Okay, so you would take your number and you would add 2 to it to get your second number. As you do more of these, it'll get easier. Okay, so can you think of how we would get our third number? Let's say we're starting with our n, our first number. Now I picked an arbitrary number 1 here, but right now we don't know what this number is. So if I want to get the next consecutive odd number, what would I need to do to 1 in order to get the next consecutive odd number after 3? We know that number would be 5. What would I need to do to this 1 to get to 5? Hopefully you said to yourself, add 4. So I would take my number and add 4. This would stand for our third number. Make sure you're writing this down with me as we go. So I'm going to erase this because this was just to kind of guide you in setting up your variable. Alright, so I'm going to read the problem one more time. 3 consecutive odd integers have a sum of 75. So we know that we're going to be adding these numbers together. So let's take our first number, n. Let's add it to our second number. We don't know what our second number is, so we're going to use the variable that we defined as our second number to be n plus 2. Then our third number would be, can you guess? N plus 4. So this represents 3 consecutive odd integers having a sum of 75. So all of this is equal to 75. Do you remember the second step when solving these? We've defined our variable. We've set up or translated our equation. Now we're going to begin solving the equation by simplifying or combining like terms on each side of the equation. So here goes. Let's combine the like terms here. We have n plus n plus n, which gives us what? 3n. And then we can also combine our positive 2 here with our positive 4. What's 2 plus 4? Good, 6. Okay, so that's our left side of our equation. On our right side, we don't have anything to simplify. So I'm going to set that equal to 75. Okay, can anyone think of how I would now go about solving this? Our next step is to solve using what? Inverse operations. So let's do that. Okay, so here we have 3 times n plus 6 equals 75. Our first step is going to be to get rid of this 6. Remember, when we're solving an equation, we're trying to figure out what our variable represents. That means we need to move all of our numbers away from the variable using inverse operations. So let's get rid of this 6 first. How can I get rid of this 6 or zero it out? By subtracting 6. What I do to one side, I have to do to the other. So I'm going to subtract 6 here. Right, 6 minus 6 is 0. There's no need to write 3n plus 0. If it's 0, there's no need to write it down. So I'm bringing down my 3n. Bringing down my equal sign here. What's 75 minus 6? 69. Okay? Now, this new equation reads 3 times n equals 69. What would I do to solve for n here? What's the inverse operation of multiplying? It's dividing. So I'm going to draw my fraction bar. Whenever you see a fraction bar, that's the same as a division symbol. So I'm going to divide both sides by 3. Here, n is equal to, 3 goes into 6 2 times, goes into 9, 3. So n is equal to 23. I'm going to put that here. However, are we finished? We haven't quite answered the question yet. It says find the integers. That means we're going to find all of the numbers. We need to know what n is, what the next consecutive number is, and what's the third consecutive number. So in this case, the next odd number here would just be, does anyone know? Okay, your second number would be 25, and then your next number would be 27. Good. Alright, so our three integers, our three numbers, are 23, 25, and 27. Just in case you couldn't do that math in your head, you could take your 23, since we know that 23 is what n is equal to, and we can plug it in here to get our second number. 23 plus 2 gives us 25. 23 plus 4 gives us 27. So this is our first odd integer. Here's our second. And here's our third. Now we've answered the question. Again, as you do more, these will become easier. Let's go on to the next one. Okay, this next problem says Megan is 8 years older than Lauren. Jackie is 2 times Megan's age. If the sum of the three girls' ages is 32, how old is each girl? Alright, first step, again, define your variables. Let's start with Megan. All of the other girls are compared to Megan, so we're going to start with Megan. Let's use M to represent Megan's age. Alright, so this says that Megan is 8 years older than Lauren. Our goal is to find out all three of the girls' ages. We need Megan's age, Lauren's, and Jackie's. So the next thing I'm trying to find is Lauren's age. If Megan is 8 years older than Lauren, how could I represent Lauren's age based on Megan's age? Okay, I could take Megan's age and I could subtract 8 from it to get Lauren's age. Remember that Megan is 8 years older than Lauren. So if I need Lauren's age, that means I would take Megan's age and subtract 8 from it. Okay? Now the third girl that we need to find the age for is Jackie. The next statement says Jackie is 2 times Megan's age. So how can I translate that into an algebraic expression? Jackie is 2 times Megan's age. Okay, I would multiply 2 times M. If she's twice her age, or 2 times Megan's age, I can multiply Megan's age by 2 to get Jackie's. You with me? Okay, so the next part of our problem says if the sum of the three girls' ages is 32, we want to know how old is each girl. So we have three answers here. We need Megan's age, Lauren's age, and Jackie's age. We know that altogether their ages equal 32. So I'm going to go ahead and set my right side of the equation equal to 32. All of their ages together equal 32. So if we're finding the sum of their ages, we're going to take each one of their ages and add them together. That's Megan's age, M, plus Lauren's age, M minus 8, plus Jackie's age, 2M, together would equal 32. Okay, next step, combine like terms. Here we have M plus 2M. What does that give us? 4M. Can I combine this minus 8 with anything? Nope, no other like terms on the left side of the equation, so I'll leave that. What about the right side of the equation? Do I need to combine anything there? Nope, I'll just rewrite 32. Okay, now again, we need to move all of these numbers away from our variable. We need to move the 4 and the 8 away from M. Let's start by removing the minus 8. What's the inverse operation of subtracting 8? You'll add 8. Okay, here, this is 8 minus 8. If you use the correct operation, it's always going to cancel out on the side with the variable. So the only thing that's left here is 4M. 4M equals 40 is our answer. Not our answer, but that's the next part of our equation as we continue to simplify. Okay, so now this says 4 times M equals 40. Inverse operation, we'll divide. What are we trying to get rid of? 4. So we're going to divide both sides by 4. Remember that fraction bar means we're dividing. So M is equal to, how many times does 4 go into 40? 10. So what is this telling us? M we've already represented as Megan's age. So Megan is 20. I'm sorry, Megan is 10. How old is Lauren? Here's our expression. If Megan is 10 and she's 8 years older than Lauren, we can plug in 10 here. 10 minus 8 is 2. So Lauren is 2. And Jackie is twice Megan's age, which means that Jackie is, what's 10 times 2? 20. Shall we move on? Sure we will. Okay, number 3. Okay, here we have Ryan, who joined a holiday coffee club that charged him a one-time fee of $15 for a coffee mug, plus $2 every time he filled his mug throughout the holiday season. If he spent a total of $43 over the season, how many mugs of coffee did he buy? First, we have to define our variable. Let's use M for the number of mugs that Joe will get or buy. So our question is, how many mugs of coffee did he buy? If we're looking for how many mugs, I'll use M to represent the amount of mugs Joe will buy. Okay, now that we've defined our variable, let's go ahead and start setting up our equation. If Ryan joined the holiday coffee club for a one-time fee of $15, that one-time fee will never change. He has to pay $15 no matter what. So let's write down our 15. Plus, here's a plus sign, $2 every time he fills his mug. $2 for every time he fills his mug, but we don't know how many times he fills it. So we'll represent that with 2M. The total he spent is $43. Okay, so his total is $43. That's what we're setting our equation equal to. Okay, so let's start to solve. Any idea of what number we'll get rid of first? Let's start with the 15. Remember, we're moving our numbers away from our variables, so we need to move the 15 and the 2. But let's move the 15 first. Just like when we say we solve equations by doing the inverse operation, well, we also solve it by doing the inverse or the opposite of the order of operation. For example, normally you would multiply or divide first and then add or subtract. But when we're solving equations, you're going to do the opposite, which is add or subtract first and then multiply or divide. Alright, so since we have 15 plus 2M, we're going to subtract 15 from both sides. I'm going to write my new equation. The 15 minus 15 cancels out. That becomes 2M. What's 43 minus 15? Okay, 28. Next step, divide by 2. How many times does 2 go into 28? 14. What does this 14 represent? This 14 represents how many mugs of coffee Joe will purchase. So 14 mugs of coffee is our answer. Okay, next one. Number 4, we have Kayla and Tanya who went shopping at the mall. If Tanya spent $104, which is 8 times more than Kayla, how much did Kayla spend? Okay, let's start by defining our variable. We're looking for how much Kayla spent. So I'm going to use K to represent the amount of money Kayla spent. Again, you can use any variable you like, but I'm going to use a K so I can keep up with who I'm talking about here. Okay, so Kayla and Tanya went shopping. Tanya spent $104, which is 8 times more than Kayla. We want to know how much did Kayla spend. Alright, let's start by representing what we know, which is that Tanya spent $104. That is 8 times more than Kayla. So we can represent that as 8K. Okay, we have a simple one-step equation here. How do we solve? We'll divide both sides of the equation by 8. So 8 goes into 104 how many times? 13. So what does that 13 represent? How much money Kayla spent. So to answer our question, Kayla spent $13 at the mall. Moving right along. Okay, let's talk about Sam and Todd, who went trick-or-treating. When they arrived home and counted their candy, Todd had 3 times more pieces of candy than Sam. If together they had 544 pieces, how many does each boy have? Okay, let's start with as always, defining our variable. Let's start with Sam. We'll use S to represent the amount of candy that Sam had. So I'm going to put shorthanded and say Sam's candy. Alright, we know that when they arrived home and counted their candy, Todd had 3 times more pieces of candy than Sam. So how do we represent how much candy Todd had? Write it down if you have an idea. Okay. Hopefully you said 3S. Todd has 3 times more pieces of candy than Sam. So you can take the amount Sam has and multiply that by 3. Alright, so together they have 44 pieces. So we need to set up an equation that represents how much candy they have all together. So we can take Sam's candy S and add that to Todd's amount of candy, 3S. Altogether, they'll have 544 pieces of candy. Okay, next step, we've defined our variable, we set up our equation. Let's go ahead and start solving by combining like terms, or simplifying. We can combine 1S plus 3S to give us 4S, and set that equal to 544. When we do that, we have a simple one-step equation. Use the inverse operation to solve for S. Inverse operation, this is 4 times S, so our inverse operation would be dividing. These will cancel out. They don't become 0, they become 1. But is it necessary to write a 1 in front of our S? No. It's understood to be there. And then 4 goes into 544. How many times? 136. Should we do the math off to the side? Let's do that quickly. 4 into 544. 4 goes into 5 once. We subtract 4 here. Subtract gives us 1. Bring down our 4. That gives us 14. 4 goes into 14. 3 times. 4 times 3 is 12. So we're subtracting 12 here. 14 minus 12 is 2. Bring down our 4. 4 goes into 24 evenly 6 times. 6 times 4 is 24, so we have no remainder. Okay, so S stood for what? Sam's candy. So that means that Sam has 136 pieces of candy. Okay. We need to know how many does each boy have. So we know how much Sam has. How do we figure out how much candy Todd has? If they have 544 total. Okay, good. We take what Sam has, since we're saying S is equal to 136, we can plug it in here. Alright, what is 136 times 3? That 3S is 3 times 136. Okay, 136 times 3 gives us 408. So Todd has 408 pieces of candy. That's a lot of candy. Okay, hang in there. We have one more to go and we'll be finished with this guided practice. Then I'll let you try some on your own if time permits. Okay, number 6. This is labeled challenge, but we've done so many problems with translating expressions that this shouldn't be much of a challenge for you. So it says Garrett is 5 less than 3 times Jerry's age. If Garrett is 25, how old is Jerry? Let's start by defining our variable. We need to know how old is Jerry. So I'm going to use J to represent Jerry's age. Alright, so this says that Garrett is 5 less than 3 times Jerry's age. Would that be written as 5 minus 3J or 3J minus 5? Hopefully you thought to yourself, it would be 3J minus 5. If it says 5 less than, that means you're taking away that from Jerry's age, 3 times Jerry's age. So we represent that with 3J. And Garrett is 25, so we can set that equal to 25. Okay, let's talk about solving this again. We want to get rid of the 3 and the 5. Which one should we get rid of first? The 5. If that's 3J minus 5, inverse operation, we'll add 5 to both sides. Okay. These two will cancel out. So I'm left with 3J on the left-hand side and 30 on the right-hand side. That's 3J equals 30. That's our new equation. How do we solve for J? If that's 3 times J, we'll divide both sides by 3. Inverse operation. So J is equal to 10. What does that J represent? Jerry's age. So our answer is Jerry is 10 years old. Okay, so we're finished with the guided practice part. I want to point out one more thing. Don't forget that all the word problems are different. So though we've done some here, you'll still have to use some of your reasoning skills and your problem solving skills and strategies to set these up. Okay, so I want you to go ahead and try the problems that are in the back. Do those in class. And I will see you on Tuesday. Make sure you get your homework before you leave. Bye.